Assalamualaikum, salam satu Malaysia, and happy afternoon, everybody. Thank you for coming to share the afternoon with us. We have three talks lined up for you today. One is on LiDAR technology, second one geospatial technologies for geoscience application, and also the third one will be the role of geospatial data in the Iskandar Malaysia project. And we have also three eminent speakers. First one is GS1 Ibnul Bahar, bin one Ismail. So I believe his biography has been circulated, but I just read out a little bit here. GS1 Ibnul Bahar, one Ismail, is a professional geospatialist and experienced CEO with a demonstrated history of working in geospatial and airborne mapping work, in particular in the civil engineering industry. He is involved in LiDAR-related education modeling, standard operating procedures, and other standardization documentation. And he has been experienced long time in Asia. I think he's the longest serving LiDAR CEO in Asia, and has an excellent degree from University Technology Malaysia in UTM, that is UTM 1985. So over to you, GS1 Ibnul Bahar, one Ismail.
Okay, thank you very much. Okay, I would like to share a bit on my presentation slides, for all. Okay. Right. Okay, can everybody see these slides? Hello?
So I think you haven't shared it yet, sir. I can't see it here.
Oh, how to share? Hang on, I'm quite new in this also. Share screen. Okay. Okay.
All right, sir.
Okay. How about this? Full screen.
All right, okay. Can everyone see it?
Yes, we can.
Yes.
Okay.
All right. Thank you very much. My name is Wan Ibnul Bahar. Thank you very much, Mr. Chairman, Professor Abdul Rasid, and also our Secretary General, Mr. Dr. Dinesh. Since my initial embarkment towards Asia on LiDAR technology, I think why not I just share with you my over 2 decades of experience in managing and introducing the LiDAR technology in the Southeast Asia. We are one of the first also to embark into this technology other than North America, in the 80s. So as part of my background, my family is from Kedah. I raised and school in Johor Bahru and Ipoh, and ever since I pursue my university education in land surveying in UTM of Jalan Geni. My working experience, other than field surveyor, I'm also a site agent or manager for some engineering project as a surveyor, survey manager, coordinator, and project director. Other than that, in experience in conventional, full flash of surveying is there, from control survey, tachymetric, bathymetric, seismic, and all. So I embarked into this GPS and so-called high-tech technology since 1990. So in LiDAR, yes, I started since 1994, having an expert in system integration and also the design of the system, integration to aircraft and all that. I have more than 10 types of LiDAR system experience. With this new drone and all that, I think it's more than 15 or 20 types of LiDAR system I already touched. From the profiling laser with 2,000 pulse per second until 400,000 pulse per second, and now not commercialized yet. They are ready at 1 million pulse per second for your info. You just imagine at the speed of light, yeah, they are pulsing about 1,000 times the speed of light now. So this technology is really, really high technology. You know, we are talking about the speed of light in measurement at about 1 million points per second. Yeah, and each second, the speed of light we're talking about at the speed of 360,000 kilometer per second. So in a way, I work from NTSC video system for the image, and now we have until 150 megapixel full RGB camera system is available. Yeah, that is for the mid format camera, and for the small drone type is also catching up for more than 100 megapixel small camera system. Yeah, the small camera system for drone, one thing, it doesn't need to be so highly calibrated, because they're flying not very high. You know, if you compare derive the tangent rule, yeah, to the ground spacing, it's not very far, because talking about only 100 meter above ground. Yeah, but if you're talking about LiDAR system on the aircraft, we fly at 1 kilometer to 1.5 kilometer above ground, then you need a very, very good camera system with highly calibrated lens. Yeah, that's the experience. We first started LiDAR system with digital still RGB color camera in 2003, for your information, which is in one Kedah project, the Padang Truck project with Macros. Yeah, first project that Macros have on LiDAR system was done by my team, and that is the data is to be given to the Prime Minister Department, I think, if I'm not mistaken. Yeah, before Tun Mahathir left the Prime Minister post. Yeah, so other than that, but actually the digital still camera was started in the early 2000 or 1999, for your information, where a team took a Kodak camera, the first digital Kodak camera at 7 megapixel from Japan, and tried to fix on a LiDAR system. Yeah, the team have tried to run this job for this railway project. Yeah, the twin double track project last time with KTM. But at that time, although the camera system is there, it's not color. Yeah, the 7 megapixel is in black and white. Very high resolution. We can zoom in to see the message on any vehicle. But we having problem at the time to integrate the hard disk system now, because the hard disk technology cannot catch up with the high resolution image yet at the time. So each snap we need about 2 second capturing of image. It cannot store that rapid now at that time. Yeah, but the current after that, after development of hard disk system and the cabling system, now the latest one is using fiber optic cable from the camera and direct to SSD hard disk. Yeah, just for your information. And we're talking about 150 megapixel already. From the early 2000, we're talking about 7 megapixel, and now 150 megapixel is ready. Full system with the Sony ISU chip, where it can also zoom in to see any features in the shadow or black area, you know. So that's the latest. So I just continue more. This is some of my previous project that I have run, you know. I just skip this, not very much. Yeah. This is one of the big project that we did. Yeah. That we also have been appointed by the government under Tan Sri Muhyiddin at the time to quickly evaluate or take the information data from Cameron Highland, yeah, in 2013. At the time, the landslides killed so many people. So we've been chosen to quickly undertake and give the data to JMG. Yeah? So until now, I would say, thank God, there's no more landslide and all that, because the government have identified which development can be proceeded and which area of development have to be prevented, you know, due to the dangerous terrain. Yeah, so the data are all by our team, yeah, provided by our team, and I think we should be proud also. Yeah, we're helping the people and the nation also to identify the best development of the area, yeah, to go or not to go. So anyway, mapping is required by all living things actually, oldest profession in the world, one of the oldest actually. And charting of boundary is for the development and planning, maintenance, upgrade the comfort and safety of the people, upgrade the income and investments. Yeah, this is the points which boundary is required. So with this, the mapping industry evolved, yeah, from the beginning, I think the beginning of human communities until now. So these are the history. Previously, I think Ptolemy have started, can say, a good chart of the world, yeah, and then when the Islamic industry came, Al-Idrisi have also charted his map, but Islamic map is pointing south at the top, you know. I'm not sure, maybe historian can guide me more. And then it evolved, yeah, until presently we are talking about the 3D map, 3D high resolution image map already in scale and digitally manageable, yeah. And currently all are in 3D GIS, yeah. So it started the aerial mapping technology from the hot air balloon, and then they put on pigeon, yeah, over France, I think, yeah, with intervals of camera captures, and the Wright brothers have started to fly the aircraft and took also aerial picture, and now currently we're talking about a multi aircraft system. We just design a pod, take the STC from the DCA, and fly the pod with all our integrated system, whatever system that we want to put, yeah, we design as for me, yeah. And currently we also have this UAV or drone system. Is more actually it's more complicated, yeah, but anyway, due to the advancement of our knowledge, it can be suited well within the range, yeah. So we're talking about survey or geometric geospatial. It's a linear measurement, yeah, firstly, and it's using algebra, trigonometry to create the angle measurement. the linear and angular using the chain and vernier theodolite system previously. The linear progresses by sound and light wave. This is using on water, where we use echo sounder. The light wave is using the LiDAR system right now. Angular refined to sub-seconds and digital control vernier. This is using gyroscope, which later replaced by inertial measurement unit. Created IMU, but in the 90s, the IMU system is military standard. So every time we want to run a project, not only we have to prepare to get approval from the local military and police station, like in Malaysia, in Bukit Aman and all that, but we also have to get the approval from Pentagon previously. And we're having a bit of problem in Indonesia at that time, where the Pentagon, very hard for them to give the approval, for job in Indonesia because of some political matters, And but recently in early 2000, they have created the IMU system using fiber optic, And until now, the fiber optic is more popular, where this is non-military standard, so we can just run without Pentagon or the European Army requirement to provide us permit. IMU is to measure the initial measurement, the attitude of the aircraft, because it's moving, So if we have a measurement system by light, it moves with the aircraft, so the attitude of the aircraft, the roll, pitch, and yaw, is moving. So if we are flying at 1 kilometer, you can measure the tangent, how much tenth of meters the measurement can be out now. But with the initial measurement unit, each of these roll, pitch, and yaw is measured in angular, so that with the height of the aircraft to the ground measured by the laser, we can compensate back, give correction to each point of the laser measured on ground. And then this is where the geometric technology has been created after that, and along with it, the computer industry also started to evolve. So geometric technology need computer industry's assistance also to evolve together. You remember when they started to create the camera, the hard disk technology cannot catch up yet, and there's no good cabling system also, like what we have here, fiber optic cable, to pass on the image data to the hard disk also. So it have to go together, In my opinion, there's some of the even professors, been they are quite confused, what's different between geometric and geospatial, but if you ask me, by my experience, because I embarked in the first geometric technology, and I embarked in geospatial technology. For me, if you ask me, I'm not sure whether this is right or wrong. I think maybe the professors in the university should know better. For me, the geometric technology is more on hardware now and software. When they create this, like that one, they create a camera system. We take the camera and try to put it in as a survey equipment. And then the cabling, the software, the hard disk, and all that. For me, that is called geometric now. And geospatial is when this technology been enhanced by GIS system, where the spatial technology starts to evolve. So geometric plus GIS and the geographically database software system, and this become geospatial. That's my my opinion on the difference between geomatic and geospatial. As a surveyor, I think I'm more on geomatic, yeah. But because geospatial is more on the programmer side, you know, the make use of the geometric data to be really applied to many industries, yeah, even in situation room, you know, where emergencies are there, yeah, to be managed, yeah. So again, I continue. This is part of my geometric experience. We designed the port, we put at the bottom there, you know, helicopters, aircraft, and all that. This is one of the multiple system on a single aircraft, yeah, where we have our this is the controller PC, yeah. This is where our operator sits in an aircraft, yeah. This is where we put the calibrated medium format digital camera, which captures imagery in a flight. Yeah, same location is used for thermal sensors if we fly at night. Yeah, we just take out this and put our thermal, or we can put just beside also. Depends on the floor of the aircraft size. Yeah, this is where we put our. This is the IMU unit, which capture the attitude of the aircraft. The LiDAR system is here, the laser system, and this is data storage for the laser. Yeah, this is hard disk with enclosed system. Yeah, which is very stable in terms of shape and also movement. Yeah. And this is the two camera hyperspectral system, which capture the scientific information of the ground of more than 500 500 information, yeah, using the very near infrared and also shortwave infrared system, yeah, using high spec system here, yeah, when we fly. So with this complete system, once we fly, we get a full range of topographical and also scientific information of the ground. Yeah. So LiDAR waveform diagram here shows that the laser when it bursts, yeah, it have multiple returns. Yeah, this is before this. There's only two returns. Yeah, the first return and the last return. You know, but after that, over the years, the industry have developed a waveform system where it goes as a wave. You know, so it capture more than two system. When I run the first profiling laser system, it's only one return, you know, on the first one, whether it's on the top of the tree or below the tree. Yeah. So after that, the industry created two laser returns, and now we have a multiple waveform system, which is basically unlimited returns, yeah, to the ground. So this is more appropriate right now with the waveform, where we try to capture as much as we can or identify the ground as much as we can. Yeah? So this is from the 80s to 90s, single profile laser, where if this block is our area of survey, we have to fly zigzag like this, you know, just zigzag like this. So just imagine, normally to create 1 meter contour, we fly at 50 meter interval for each of our lines. which create a lot of aircraft time. You know, it's very expensive project. Yeah, one of our first project, the pilot bought their own the helicopter himself. You know, because of the long flying hours he got from this job. Yeah, this is the single profiling laser on the first 90s last time. So full waveform sample view is like this. Yeah, it goes everywhere and capture the ground as the orange points. Yeah, it's already been processed. Yeah, where all the others are vegetations and branches. So this is part of the smart city precise GIS. This is Geospatial already. Where we're talking about right now, we can provide until 2.5 centimeter pixel size, yeah, everywhere in the city, at the best view with the angular. This is also city mapping, yeah, very high resolution for many applications. This is one of the latest that there is. And the latest high resolution area camera from IGI can see at they're using 8 numbers of 150 megapixel RGB camera, yeah, mounted here, yeah, and it's very high resolution, yeah, capture up to 0.6 second frame rate for all the 8 camera system, yeah, it's very high. This is how it looks like, yeah. The sensor, where each of these represent hard disk to capture of, to support each of the camera that there is, the 8 camera system. Yeah. Okay, but again, this is no LiDAR system, so it's only good for cityscape. Yeah. We have this in Malaysia. Tell you it's going to be great. Yeah. But if we put the LiDAR system also, we can also capture below the treetops around. Yeah. This is some sample. Yeah. This is in Bangsa, and this is in Padang Terak, yeah, in Kedah, jauh mattress last time. So now there is a 1 million hertz LiDAR system with a camera of 150 megapixel, but this is non-commercialized yet. Yeah. How about mini airborne LiDAR system? This is Kevlon by gyrocopter. I have this experience when I was in Germany previously. Yeah. I tried to introduce this in Malaysia and Indonesia, but having hard time because this is considered as a hobby craft. Yeah, it's not meant for working. So, but just to share with you, this is a capable system where the laser and camera system is here beside the pilot. Yeah, it's mini system. This is using the UAV or drone LiDAR. So the LiDAR has embarked into drone system right now with a very small system. This become available due to the technology of battery now can last longer, and also due to the good technology of the camera and to minimize the size, you know, like computer system last time is very big, now become very small, now become in computer system even on your watch. Yeah, so this become available right now, and mobile LiDAR is there also. Yeah, so this one, if you want to see, this is one of the, just want to share with you. Open. Okay. Yes. This is one sample of drone LiDAR, one of the latest one, which doesn't need a landing strip, yeah, to go and fly. So it just go up like that, yeah, like a helicopter system. But helicopter system, if fully consume a lot of battery, yeah. But after it go up, it just go glide to the area of survey. It just go glide, you know. So it save battery, yeah, with this system, yeah. Okay. So I think, yeah, mobile LiDAR is also there. Yeah, you just put in the car, on the car, calibrate it, and just drive. Yeah. So this LiDAR technology to the survey industry is have a very high advantage actually for us. Yeah, I'm a surveyor, but maybe I'm lazy to go on ground because for me it's not. I wish my expertise now of going to the jungle, rintis, you know, pick up points. But for me, this new technology in survey like this, yeah, you can really do wonders. Yeah, just run. And I've done several LiDAR projects previously. Yeah, sometimes in one day I can cover more than 10,000 hectares. You just imagine, yeah, with more than one spot heights in every square meter, everywhere in a remote jungle of Kalimantan, where the trees are averagely at the height of 50-meter high, you know, canopies. So these are some of my experience that I like to share with you all, and I hope it can benefit well, yeah, towards the more advancement of the system that there is, yeah. Thank you very much for now.
Thank you very much, GS Ibnul. Thank you for giving the overview presentation. And I wonder, any questions from the audience, you can ask now. So while we are waiting for the questions, GS Ibnul, you mentioned just you also do thermal scanning, huh?
Oh yeah, yes.
What is the temperature resolution that you are able to capture?
Oh, when we did the thermal project, yeah, the resolution we are capturing at 0.3 to 0.5 meter resolution, yeah. But the point is the difference in thermal values, we're talking about at 0.001 degrees Celsius difference, yeah. In Australia, they use this to evaluate the building top now, you know, at night, yeah. So they want to see which building is still hot now, even at night time, you know, because the municipal believe if they can have this information, they can put like maybe more greeneries at the top of the buildings and so on. And this can save the electricity of their air conditioned power, yeah. And over the year, they believe they can save hundreds of million Australian dollars due to the due to create this coolness in each building, you know, when they can identify the building exact difference in the height, in the heat, yeah. And also for recreational area in the township of Perth, let's say, they can identify also which part of the area is hot than others, you know. At the hot area, they intend to put more way for the wind to breeze and put more trees, yeah, so that the recreational center become more cozy to be built in. So this can be applied for Malaysian also in a way, you know. So this type of information is very important. Yeah, maybe some municipal and all that not aware that this technology is already there. So we have to put more time, to see them and educate the people within our industry of IGRS.
Yes, sure. Also, I think with the issue of energy now in the sustainable development, so the capturing such information will play an important role. Furthermore, I think when you have pipelines of gas and other transportation of inflammable material, the temperature differential also may be a good guide for the safety aspect. Now, a second question I'd like to ask you is about the requirement of you want to call them geospatialists or geometric engineers or surveyors. How many of these do you think this country needs within the next 5 years in the area of LiDAR mapping?
Wow. I think for me, for each of companies, that there is, let's say, I think all of them, all of these surveyors, need to understand about geometric and geospatial technology. It's a must now, right now. It's a must. We don't have anymore a surveyor who go to the field and pick up stones and all that all their life. They move now. Even my friends in the survey department also, they move from department and department. And every one of them I can see have to know the geometric and geospatial of the industry. It become a really necessity right now. If if really you lose the time, you really have to catch up. So if in our Malaysia we have maybe 100,000 surveyors, for me 90% you should know about geometric and geospatial. That's my advice to this.
Yeah, these are actually just modern tools for collecting the information and for storing and for analyzing it. Earlier on, we used to call it land surveying in Malaysia when you were a student in UTM called Ukutana, I believe. And later on, now we call it geometric. And this field, geometric, is just from the word geo, which is surface of the earth, and metric means the measurement. So traditionally we use surveying, and now we use geometric. But the new tools come in, the GIS come in, the GNSS comes in, the remote sensing comes in, and those who ventured further, we call them today in Malaysia. We use the term geospatial. Geospatial for the people into the GIS, remote sensing, GNSS. Now we even have the supercomputing and the big data and so on. But by law, we have also the cadastral surveyors who play such an important role in maintaining the boundaries and determining ownership. So this is controlled by a specific legislation, and the cadastral surveyors are what we call them the licensed surveyors in this country. But really, the geospatial field is very open field, and as you say very correctly, the technology has to be mastered by all of the students who are taking up the geosciences, because you may be a geologist, you may be an urban planner, you will need these tools to get the important information to do the analysis. Also, for this reason, you see the word geospatial used of commonly with the word information, because from the data collection, it is collected into databases, and that's where the intelligence is built in later on. Very smart analysis and decisions can be made. So that's a background. Maybe I will follow on separate issue on the projection for number of geometricians and geospatialists we need, because I think with the RM12 coming out now, we should be able to give the government some projections on our requirement. And for those of you in the audience here who have connection with government, kindly lobby with the government. We need to increase the number of geospatialists, the number of geometricians, and we also want to get the position Juru Geospatial, to have more of this position in the government department. This will help us to contribute much more in the new normal.
where we need much more support from the geosciences infused into the various government departments. Yeah. So now I think, is there any other question from the audience?
Maybe I can add a bit more. Yeah. As for my latest update, my partners are professional engineers, professional geologists, professional geophysics, So all this become one already right now. We're not, we can't do just focus on mapping, survey only, We have to know the other system that can be integrated to become geomatic, as a tool to measure matters. So again, I'm combining three type of industry into geomatic: the topographical industry, the scientific industry, and also the geophysical industry. So we also have a radar system and all that integrated to aircraft already. For your info, other than laser, camera, hyperspectral, we also have a sensor that can measure gas, for pipeline gas,
Ibnul, Ibnul. There are two questions that just came in. Sorry that I had to cut you off there just now. The first question came from the audience is that, can you please advise on the most appropriate LiDAR system for 3D city mapping and vegetation monitoring?
Yeah. So for this, if you ask me, what you need, you need a LiDAR system, if possible to have two systems which can capture in angle, or we can also just use a single one with control overlap, So if your building is lining like this, you don't fly your LiDAR parallel to it. You fly across it, so that you can capture, something like that. You have to really design yourself. That is for the city mapping, and also for vegetation monitoring. You have to also put integrated hyperspectral system to it, so that you can identify what type of vegetation is that, and what is the health value of the vegetation. But again, for city mapping, maybe you don't need even LiDAR system. You just need a camera system like what I share with you, with the 8 camera system, with vertical and also side view. You just fly, and with it you can after you apply the correction, you can create, I think about 50 to 100 spot heights in 1 meter square. It's up to you, and the intensity, the resolution of the camera, you can combine to create a mosaic up to 2.5 centimeter pixel also. Again, if you want to add with vegetation, you add in the very near infrared hyperspectral system. That should be fine.
Okay, thank you for that. And there's another question here. Can you share your experience, if you have, on integration of LiDAR with hyperspectral?
No problem. One of the slides that I have put there does show an integration with hyperspectral, LiDAR, and also camera system. If you can remember, maybe I can show you again. This one. Share screen. Okay. Okay, you can see this one, where we have a LiDAR system, the controller computer, hyperspectral system is put here. LiDAR is here. Okay, and we can also put the camera system here. It depends on how you design the whole of your aircraft. So again, you can see the knowledge we have for just a surveyor is not enough. You have to know electronics and all that. aircraft system, the voltage, everything, yeah. And then you become a good geospatial or geometric engineers. Yeah. Okay, you can see this, yeah.
Yeah.
Okay.
There's a third question. Can you put that question again, GS Dr. Indonesia? The third question is, with that more advanced system and a higher number of points in modern LiDAR data, how do you handle the processing of the errors made by the recent LiDAR system? This is the question that came in. Well, basically asking you how do you handle errors in with a higher number of points?
Wow, to handle errors actually is the difference between each of the LiDAR surveyor, for your info. You know, I still remember in 2000, a LiDAR system with a new company came in and did job in Sabah, yeah, and we've been outbid by the new company, so-called, but the data after that is a mess, yeah, because they don't control the error system, yeah, the error information that there is in the data. For us, that's why first and foremost, we have to, you know, identify how we're going to calibrate our system, and then how we're going to check our system. So every time, yeah, when we want to start our flying, we will check first, you know, before we acquire the data, and after we fly back, we have to check again after we fly the area, yeah. And in between the area, we have also some points where we have pre-marked, yeah. We have run our GPS on ground, very detailed GPS, to identify the exact point on the ground, you know. Again, this apply also to your knowledge on GPS, yeah. The static and kinematic GPS, you have to apply that now, you know, all your knowledge to this LiDAR information. This is very important. And after you process also, the processor have to understand on the processing, yeah. For each of the LiDAR run, they're going to be sometime error, floating error, yeah. And how you're going to match it and all that is, again, you have to apply that, yeah. And as a QC, after the end, the QC surveyor have to pick up all the GPS point that they have laid before the LiDAR survey and apply to the data, so that they can, if there is a shift, they're going to apply a constant shift, yeah, to get the best ground accuracy that there is to the data that's going to be submitted to any engineers or scientists to be used.
Yeah, thank you on that. The next question we move on is on the pricing. For the current system that you have, what is the price range for per square kilometer for LiDAR survey? And is there a possibility of reducing it further to make it more sustainable?
There is the price been moved from very high to very good supportive range for your info, you know. Let's say because it depends on the size, yeah. If your size is small, of course the rate going to be very big, because several days you just play around with the aircraft without really acquiring the data yet, yeah. But you compare with the MOF rate, let's say 1 kilometers, 1 hectare, yeah, I think it's about 742 ringgit, yeah, per 1 hectare to create a 1 meter contour, yeah. LiDAR easily can do, I would say easily can do only 100 ringgit per hectare, yeah, if the size is big, with not only the 1 meter contour, yeah, with the spot heights of 5 or 7 spot heights in 1 meter square, and also you have a very high resolution imagery to the system, and with the DTM in the image, you can apply fuse it together to create 3D image in GIS now. So that is the advantage on LiDAR system to the survey industry, very, very much. Yeah, that doesn't also mention about also apply the hyperspectral data, the geophysical data to the same LiDAR survey information. That would be marvelous, actually. Yeah.
Yeah, of course, that's the economy of scale. The larger the area, the cheaper it becomes. And finally,
Sure.
a last question for you, GS Ibnul. Somebody very interested in this field, he asks you, what does it take to get into the LiDAR operation industry and use it as a career path?
Wow, you have to drive yourself.
They want to be like you.
Okay. 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 If you ask me personally, I would say I'm a very lazy surveyor. but I took my responsibility very high, you know. So other than doing the survey work in daytime, yeah, at nighttime I took computer class. Yeah, I bought a book on how to be a programmer. I create my own software now previously, yeah, and I drive myself. I join in international companies, geodetic, yeah, out of Switzerland, yeah. They send me to Brunei High Sea and all that. Only me alone as a Malay and Malaysian, you know. I don't care, you know. But I took it very serious, yeah. I want to really make this survey industry to become fundamental one day. So I think I have done that well, yeah. Because in 2005, the survey department did call me to give this talk to all the pengarah, yeah, in Japan 2 times, yeah, at that time, to talk about the advancement on survey data capturing using this type of technology. So again, you really have to drive yourself. You have you learn about computer programming and all that, so that you know. Electronics also you need to understand, yeah, and make friends with all the related LiDAR people and GIS, you know, and good luck to you all.
Yeah,
Right.
thank you, GS Ibnul. Now,
Sure.
there is obviously greater interest and demand in this. So we will welcome you and your company to work with IGRSM to popularize and promote this technology among the Malaysians and also for our overseas members. Now, also, a local university have offered master's program in GIS, remote sensing, and related fields. So within these programs, we also offer the LiDAR as one of the subjects. And there's scope for us to cooperate with the local industry to help build excellent graduates who can later on serve the industry. Okay.
Wow.
With that, let's look for greater cooperation among all the players in Malaysia.
Sure.
So with that,
Yeah.
we need to thank you in our normal way. Let's give a big applause to GS Ibnul for his time preparing and answering a question here.
Yeah.
Thank you very much, GS Ibnul.
Yeah.
So we move on to the next talk now. We have actually GS Rasid lined up to talk on the geoscience applications, but unfortunately, at the last minute, he was called up for some important task with the federal government. So he has sent a replacement, Muhammad Dali, who will speak on his behalf. Muhammad Dali obtained his first degree in geology from National University of Malaysia, UKM, not far from here, just in Bangi, and obtained it in 2015. And currently he's doing a master's degree in disaster risk management at the University of Technology Malaysia, UTM, in KL. Now, he's a registered graduate geologist with the Board of Geologists Malaysia and has a number of other professional affiliation as well. He has had the opportunity to work closely with different professionals throughout his involvement with development projects. So welcome, Muhammad Farid, Muhammad Dali, and please deliver your talk. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Thank you, Mr. Chairman, and all speakers, audience. So let me share my screen first. Okay, can you see my screen?
It's online now, sir.
Okay. Okay, all right. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all. So basically, I'm representing Mr. Rasid because he got a very important, urgent, and short notice meeting this afternoon. So I will share on the geospatial technology for geoscience applications. So basically, this paper is prepared by it's a teamwork of preparation. This paper based on our experience and also some resources from available sources. So on behalf of Mr. Rasid, I will present this paper. Okay, basically Mr. Rasid is this is the qualifications or affiliations of Mr. Rasid from the academic, professional, academic affiliations. He's the exam professor at UMK, UTP, and also University Malaya. And also he's currently the president of Geological Society of Malaysia, as well as vice president of SCGRM, Society for Engineering Geology and Rock Mechanics Malaysia. Okay, and a few other affiliations, professional affiliations. Okay, so this is my information. My name is Muhammad Farid, and I getting my PhD from UKM in geology, and currently I'm going pursuing my secondary with UTMKL in Industries Management. I also registered with the Board of Geologists, Geological Society of Malaysia, as well as SCGRM. And currently I'm working as a geologist in Geomapping Technologies in Bahar, based in Bangi. So basically, before I jump into my main topic, I would like to share with you our Geoscience pyramid in Malaysia, the professional, learned, and trade geological organization in Malaysia. So actually our profession is governed by Board of Geologists, Lembaga Ahli Geologi Malaysia, incorporated in 2014, under the Act of Geologists Act 2008. Apart from that, we have also GSM, Geological Society of Malaysia, incorporated in 1967. This is the oldest geological association in Malaysia. The aim is to promote and advance the science or knowledge of geology within this region, not only Malaysia. And the third is IGM. We have IGM, Institute of Geology Malaysia, which incorporated in 1989 to promote and enhance geological practice and profession in Malaysia. And now our new baby is MyGeo. Okay, so basically MyGeo is a Malaysian Geoscience Consultant and Services Association. So just incorporated this year, aim to represent, promote, and enhance the technology and practice of geoscience consultancy and services in Malaysia. Okay, so this is my outline. Actually, I got 70 plus slides. Okay, but it's a lot of slides. It's a lot of slides, but I try to quickly jump into each topic. Okay, start with introduction, and I will share with you about the geospatial technology in mining inquiry, oil and gas, construction industry, geological hazards and disaster risk management, and understanding the advantages and limitation, and lastly is the conclusion. So when we talk about geospatial technology, what we understand is there's a 4 pillars of geospatial technology. Start from remote sensing, a geographic information system or GIS, global positioning system, GPS, and also internet mapping technologies. So basically, these 4 pillars of geospatial technology is integrating each other. Okay, we cannot play with this remote sensing without integrate with GIS, for example. So what remote sensing can provide us is to to have imagery and data collected from space or airborne camera and sensor platforms. So for GIS, it's a suite of software, as Mr. Ibnul said, it's a software or tools for mapping and analyzing data, which is georeference, assign a specific location on the surface of the Earth, or we known as a geospatial data. And for GPS, a global positioning system is a network of satellites which can give precise coordinate locations to users with proper receiving equipment. And internet mapping technology is a software program like Google Earth and web features like Microsoft Virtual Earth that changing the way geospatial data is viewed and shared. Okay. So what geology or geoscience industry in Malaysia, what we do actually? So actually we involved in 8 industries. Start with oil and gas, civil works and construction, environmental study, environmental industry, groundwater industry, mining and quarrying, agriculture industry, government agencies, as well as universities and research agencies. So these are the 8 industries that we involve with, and this is where we currently utilize geospatial technology in doing research or doing services to provide to especially to the client. Okay, as an introduction, actually before we start, we actually need to understand what geoscientists do. Okay, geoscientists is study of the structure, composition, and changes of the Earth over time. Usually, practically or traditionally, we need to go to the site to observe any geological or geological structure or geological information. But sometimes not always practical for geoscientists to visit the site, maybe because of the limitation on the accessibility, very dangerous, or sometimes in the middle of the jungle. So the use of remote sensing in geology means that we need to gather detailed information from not even a very specific place, but also from around the world, very much easier. Okay, and then the interpretation and visualization of the data from this distance sensor or distance remote sensing tools is one of the primary uses of geospatial technology for geoscientists. Okay, so I move to the first part, which is geospatial technology in mining and quarry industry. Okay, in mining industry, geospatial is valuable when mineral exploration by remote sensing and GIS leads to efficient prospecting. So the keyword is prospecting of the mining and quarry. Geoscientists identify potential deposits by mapping surface characteristic and performing spectral analysis. As I said before, site observation or fieldwork is very important to have a surface characteristic of the area, as well as performing spectral analysis while using remote sensing or geospatial technology to select a suitable combination of spectrum that is useful to detect a mineral or quarry. For example, here Landsat 8 can produce 8 different bands, but only a few of them are appropriate for general remote sensing, and even fewer are used in mineral exploration. I think internationally is very common to use this kind of technology, but in Malaysia, I think still few of the mining operators using this technology. Extensive data and the ability to use spatial thinking skills make it possible for geoscientists to work effectively and make educated decisions about where to drill or where to get the mines. Okay, the use of maps and 3D models or DM of the specified area also allowing for further use by scientists for the future work plan or analysis. So I give you some example on the mineral exploration. Okay, for example, here is a RGB 432 band. It shows an approximate natural color showing strong iron oxide soil coloration. Rocky outcrop appear in patches of blue, gray, and or beige. So you can see that the color of iron oxide here, and also the rocky outcrop here can be seen by this band. Okay, when we change to the other band, okay, band 5, 6, 7, we can see the boundary between regolith. Regolith is shown by the shades of blue and outcrop, as well as differentiating rock types in outcrop itself. Okay, and then when we change to the different band 752, we can produce an enhanced image with rocky outcrop. For example, here we identify as quartz porphyry, basalt, and quartzite. This is the different geology or lithology. shown in shades of purple and blue, and many structural features where lineaments, faults are visible in the full-size image. Variation in regular geology appear as a patchwork of yellows, browns, and green. Actually, this band is ideal for geological investigation. Okay. So before this, we are focusing on the mineral exploration, and then we move to the modeling part. Okay, geospatial data used to generate a ground model of mining and quarry area. So the popular one is a use of a UAV drone or LiDAR, usually deployed to capture aerial photograph as well as scanning the terrain. For example, the photo shows the setting up a ground control point (GCP) to tie the images to the desired coordinate system at maximum accuracy. So when we fly UAV drone or LiDAR, so we need to have a GCP or ground control point to tie the elevation, so that the elevation we get from the UAV or drone is a true elevation that correlate with the ground control point. So this example of setting up flight path for the UAV drone to maximize the coverage within the area of interest. For example, here we setting the flight path so that the drone can fly it. And then the product is the aerial photograph that stitch and overlay to produce panoramic aerial photograph. For example, in quarry here. Okay. And then from this aerial photo, we can have a dense 3D point clouds generated from the data captured. Okay. Thank God, because this is a quarry, this is the quarry, so the vegetation is very limited, so we can have a ground elevation very nicely. And then from that we can generate a contour, and from there also we can generate a DEM model. Okay. From this DEM model, we can do, for example, here stockpile management. Okay, from the UAV drone that we conduct before, or photogrammetry that we use to capture aerial data and produce 3D model profiling, is useful to estimate the amounts of ore, waste, or overburden generated by mining operations. Of course, ground-based surveying method is very important to have a ground control point. And then the updated 3D surface model provide recurring snapshot of changes in the life of the stockpile. So basically, for mine operators, this data can be plugged into any mining or GIS software, so for the analysis and evaluation. Okay, for example here, of course, for mining or quarry industry operators, usually they have a regular survey, so that they try to they have a regular elevation data on their quarry or mining site. So what we do is we generate the DEM model from the OGL survey point initial observation, and then from the UAV or autophoto that we fly, okay, we generate the point clouds using a drone, and then after that, of course, as I said before, we generate a new DEM. I mentioned, it's a final observation, new DEM, and then we can calculate the cut and fill stockpile, so that we can see the differences between the initial observation and the final observation. Okay, cut and fill with command or tools, usually in GIS, embedded in GIS software, used to calculate the volume of stockpile by taking the differences between as-built DEM or initial DEM, the final DEM and the OGL DEM. For example, here blue is a volume of cut area, and red is volume of fill area. So we know mining and quarry area, usually they cut the rock or the soil, and then they dump into one places. Okay, so this technology we can use to as a stockpile management tools. From that, the same technology or the same concept can be used in operation monitoring. Okay, so for example, we have a tailing dams, which usually tailing dam have a content of toxic materials and semi-solid phase. So by using this technology, by using drone or geospatial technology, we can there's no longer to be close proximity to the area, the dust and dangerous substances. Okay, drone surveying can be done from line of sight distance, and of course, as I said before, can generate a 3D model of telling them the information such as existing volume, threshold volume projection, cross section, and slope monitoring can be obtained, can be used. Okay. This information also important to calculate the cost and design for future maintenance of the tailing dam. Okay, I show you the example on how the 3D model of tailing dam generated by using point cloud. The same concept as I show you. Okay, and then within the same information, we can do a slope monitoring. Okay, it's very important to monitor the slope movement, slope failure, and erosion. More advanced, there is a technology with the thermal sensors attached to the drone or to the UAV that monitor the tailing dam to capture any leakage into the leakage incident without risking chemical exposure to the personnel or to the worker, identifying observe at site. Okay, and then in mining inquiry also, of course, there's the drilling and blasting works. So by using the same concept, the DM, 3D model, or photogrammetry, we can use to optimize it for the blasting process to increase the operating performance and reduce cost. Okay, for example, here we can identify which blocks that we are going to blast. Okay, and the same concept, we use a cut and fill analysis to calculate the volume of the estimate blocks. Okay, of course, once we do the blasting, we need to follow all regulation from the authority. For example, the authority that regulate the blasting regulation is JMG. Okay, so in order to report to the JMG, we need to have photos, for example, to monitor and analyze the blasting behavior, so that we can show them that we are follow their regulations in blasting operations. I move to the second part, which oil and gas industry. So as you know, 80% of the oil and gas industry is driven by the spatial component from the early stage of life cycle, beginning with opportunity analysis and exploration, and even in abandonment phases of the oil and gas, for example, oil and gas rig, we need the geospatial component. GIS technology or geospatial allow us to manage the spatial component of this petroleum business, such as leases, wells, pipelines, environmental concerns, facilities, and retail outlet. Okay, usually for onshore exploration, which we drill oil on land, okay, is often include analysis of satellite imagery, digital aerial photograph, seismic surveys, survey geology studies, subsurface, and cross section. The same concept of what we do in the mining industry. Okay, but for offshore industry, of course, imagery is not, it cannot be used because there's a sea, only sea that we can identify. So this offshore industry, usually we are using geophysical survey, but this geophysical survey must comply to the GIS-based seabed survey data model, or SSDM, which is developed by the International Association of Oil and Gas Producers, IOGP. This SSDM is an industry standard for how survey data is stored and managed by oil and gas companies. So the geophysical survey for offshore exploration must comply with the GIS-based data storage. This is example of the cycle of GIS deployment through the oil field life cycle, as I said before. Okay, and then this is example of how GIS or geospatial data is visualized, integrated into one component. Okay, we can see the green line is the pipeline, and so the dot is the well. So they put all the information on one GIS interface. Okay, so the label is where to drill, where is the next oil, the next well to drill, and also the alignment of the well. So this is easy for them to manage the operation. Okay, this is an example of offshore seismic survey. where the survey this geophysical survey need to comply with the SSDM as I mentioned just now. Okay. Okay, I move to the construction industry. As an introduction, modern construction, considering durability, sustainability, resilience, and incorporation of geospatial technology is the way forward, and it will revolutionize the construction industry, make it more tuned with technological advancement as well as the needs of the people. Okay, so this geospatial technology used to provide engineering-based solution, especially for modeling, monitoring of slope deformation, rock mass characterization, and additional insight into any underlying failure mechanism. So this is an example of the tools or geospatial tools that we use in construction industry: TLS, UAV, LS, SAR, and also several prominent methods. Okay. So I give you one example on the use of 3D photogrammetry in slope modeling and monitoring. Okay, for example here, 3D photogrammetry model of a slope, granite slope, captured by the camera. Okay, and then by this photogrammetry model, we can identify, we can use this into, and we can put the model into kinematic software to identify the discontinuity and use for kinematic analysis. After that, after we identify the discontinuities, we put it and we correlate with the deterministic analysis by using relevant software. Okay, so this is the visualization of the photograph on the site condition itself, through site condition, and then we put in a model of how the, for example, the blocks behave, okay, and how it feels. Okay, by the same method, we can provide a visualization of the mitigation measures. Okay, by the 3D photogrammetry, of the slope, we do present where the slope mitigation need to or where the robot need to install. For example, here. Okay, so it's easy for the contractors or for the consultant to visualize and to see at site the true location on where to install the robot. Okay. Apart from that, we also can use terrestrial laser scanning. Okay. The same concept where we scan the rock and then we produce a model, and then from this model we identify the slope instabilities. For example, this one is the identifying slope instabilities for highway construction project. Okay, this is the highway alignment. We can, by using the TLS, we can identify the debris and the potential rock slope, hanging blocks, for example, and also discontinuities. Okay, this is some example of utilizing UAV LiDAR in geohazard identification along the same highway ongoing construction project. So by using LiDAR, we can generate several factor maps. For example, hill shape, we can generate topo openness, slope gradient, etc. And with these factor maps, we can utilize to identify landslide. For example, debris flow, rockfall, and also landslide. Okay. So apart from that, in construction, we also integrate the GIS or Geospatial into BIM or building information modeling. Is a very popular tool now in managing construction progress. Okay, is this BIM is an intelligent 3D model that give architecture, engineering, and construction professional the insight and tools to more efficiently plan, design, construct, and manage building and infrastructure. Okay, you can read the information here. Okay. Okay, this example of integration of GIS or geospatial data into BIM. Okay, start from the data captured, and then we store into the updatable data interface, and we put in a database, and the last but not least is the portal accessible by the PC of the client. So the client can monitor all the progress of the works by using this concept or this BIM. for then we move to the earthwork monitoring. In the past, it is difficult to monitor the earthwork progress, such as proving how much dirt had been removed and who was responsible for it. Without the detailed log of changes in stockpile volume, having to move someone else's dirt was all common. By conducting the same UAV or drone survey as a visual, detailed account of whose dirt, where, and when can be properly recorded and monitored. Okay. For example, here is a earthwork progress monitored just using a photograph or drone. Okay, this is for the year of 2013, and then we can see the progress of 2016, and then the progress of 2018, and last but not least is 2019. So we can see the changes. Of course, this is a very important record, so that we can report the progress of the project. Okay. Apart from that, in the earthwork monitoring, also we can use as a amount of how much excavation had been conducted. Okay, the same concept as stockpile management. Okay, we need to have initial topography, and then we need to have an excavated finish level or second observation, and then we calculate the total cut and fill area based on information of the boreholes or site investigation, and then finally we estimate the cut and fill volume in the area of excavation or construction. Okay, this is another example or another method on how we do earthwork monitoring. Okay, I move to the next use of geospatial in hazard and geological hazard and disaster management. Okay. We need to understand the definition of hazard first, or disaster management first. Disaster risk management is the systematic process of using administrative, directive, and organization and operational skills, capacities to implement strategies, policies, and improve coping capacities in order to lessen the adverse impact of hazards and possibility of disaster. UNDRR is the United Nations Office for Disaster Risk Reduction. So this is a disaster risk management cycle. So basically, the 5 phases utilize GIS or geospatial information. Okay, once disaster occurred, and then during the response, we need to have maps where to go, for example. And then for rehabilitation, we need to have a evacuation map. Okay, and then for prevention and mitigation, of course, we need to have a hazard map. And for preparedness, we need to have where is the evacuation location that we prepare for the evacuees, for example. Okay, basically the GIS or geospatial is very important in disaster risk management cycle. This is an example of how GIS and geospatial can be utilized in the disaster management cycle. Okay. Okay, in Malaysia, for example, we have MyGeos or Malaysian Geospatial Online Services, where this is a portal of collaboration between the government agencies to monitor to share the geospatial information about the disasters, as well as for example here, even potholes also can be monitored. Can be monitored by the public works department, where they used to use the application or the MyGeos to facilitate the required road repair and maintenance. So for example here, the flood in Cameron Highland and also in Kelantan 2014. This portal is useful to store and collect the information on the affected areas. The data collected in these 2 events is stored in the application, and the damage assessment team on site shared the MyGeos information into the command and operation center in real time. So for example, in daily basis. Okay, this provide teams with greater situational awareness, enabling them to respond and mobilize resources in the most efficient way possible. Okay, another example is a flood in Kelang Selangor, coastal flood in Kelang Selangor. So this project is conducted by Selangor Disaster Management Unit, okay, where they deploy a UAV for aerial photograph mapping, and they produce a DEM based on the point cloud for aerial photograph, and of course they tie with several GCPs, and they produce a flight hazard map based on DEM provided. Okay, so they use the same concept of aerial photo to produce a DEM, and then they use the DEM for flight hazard map generation. Okay. Of course, in landslide also we use, for example, LiDAR to study, to investigate on the landslide. For example, here LiDAR method by is an example of LiDAR visualization, and this is the site observation where we can see boulders in the river. Okay, same goes to this one. Also this one we can see during using the LiDAR or shape, we can identify landslide erosional features. Okay, as well as this one, maybe a Google Earth or aerial photo also can be utilized. Okay, this is the same example as I mentioned before, and this is the detection of new and old landslide using geospatial technologies. Okay, this is the case study in Sabah, where we where the JMD fly the LiDAR to capture the information of landslide as well as the debris flow path. Okay. Apart from that, in JL also we also use in the rockfall hazard zonation. For example, here we deploy UAV LiDAR to identify hazard limestone hill. Okay, this is the hazard limestone hill. And apart from that, we also integrate with geological fieldworks or geological observation on the risk continuity and also joints in the area. And then we also conduct a site observation of the to see the actual actual joints or fault that we identified. Okay, and then we also do a deterministic analysis on the rockfall simulation, and lastly we provide a buffer zone. So basically the integration between the GIS, geospatial information, and with the suitable software that we simulate rockfalls, and even field observation is very important to provide this information, a buffer zone or safety zone. So this is important for disaster managers in this particular area to plan the evacuation and development of this area for the next phases. Okay, this is an example of a GIS in landslide disaster in hazard, vulnerability, and risk mapping. Okay, the most important thing is the identification of the landslide itself. Okay, landslide inventory map. By using LiDAR, we can easily identify the potential or the landslide scar here. Apart from that, we also identify the critical infrastructure or element at risk. Okay, where we do map or we digitize the roads. For example, the red one here is the roads, and the blue one is the houses, and this one is a plantation. And this is the case study in Cameron Highland, the plantation agriculture, and this is the dam. Okay, in Cameron Highland can be identified. And after that, we do a landslide exposure map. Okay, this is based on the GIS calculation or algorithm, and then we generate the landslide hazard map here. Okay, and by having a landslide hazard map, we calculate the vulnerability of the element at risk, and then we provide the risk map for the. This is useful for for example, district office to monitor the hazard area as well as to monitor the element at risk itself. Okay, and okay, then we move to the sinkhole disaster. Is a very usual, is very common problems in limestone formation rock. For example, in Malaysia, we have limestone in Kuala Lumpur, even Ipoh, Gomosa, and also Perlis, and also some other several parts of the country. Okay, Traditionally, sinkholes discovered by field observation. We need to go to the field to see the sinkhole, and sometimes sinkhole is discovered when the sinkhole is already happened. Okay, but recently, a remote sensing approach by using LiDAR and GIS technology helping identify surface clues. Okay, the clue is surface clue to identify underlying karst formations or limestone formation for large areas, including whole, even in whole states. Okay, when analyzed on the GIS map, LiDAR can pinpoint underground karst activity. For example, here this is the observation on the ground, or using the aerial photo, and then this is DM visualization where sinkhole is identified. Okay, this is example of aerial photo where we identify the sinkholes. And then from the same geospatial source, we can identify the 2D model or 3D model of the point cloud, so that we can see the sinkhole here. For example, here you can see the sinkhole, and we can model it to make it presentable and make it reliable to the planners or to the authority, so that they are really care or really careful on these potential sinkhole incidents. Okay, after this geospatial utilization for geoscience application, what we can see on the advantage of this geospatial is it has the ability of improving the organizational integration. For, as I said, it's very important to plan. For example, inquiry or mining area, it's very important to plan the operation. Apart from that, it also allow viewing, questioning, and understanding, interpreting the data into a number of ways, which will reveal relationship, trends, and pattern in the form of globes, maps, and charts and reports. So we can use the GIS information to represent in a different way of presentation. Okay. Of course, it reduces cost and time for conventional fieldwork. Okay. GIS also provide help in answering questions as well as solve problems through looking at the data in a way which is easily and quickly shared. GIS technology also integrate into framework of any enterprise information system, and also, of course, there's a number of employment opportunities. But there's a limitation on the geospatial for geologists. Okay. Of course, geospatial technology usually require expensive GIS software. For example, ArcMap, and then for mining we have a SAPAC, several software that is GIS based, so it's very expensive. Secondly, since the Earth is round, and so there will be a geographic error that will increase as you get into larger scale. Okay, and there might be a failure in initiating additional effort in order to fully implement the geospatial technology, but there might be a large benefit to anticipate as well. Its technical nature may portray result as being more reliable than they actually are, and the errors and the assumption can be hidden, leading to lack of questioning into the results. And then the issue of analyzing the result from geospatial technology is that the result will be only as accurate as the data that they come from. So the data may not be able to serve different contexts, particularly if the data is not applicable. So for geologists, the most important thing that need to be done by utilizing geospatial technology is still the field observation. Okay, fieldwork is very important. Once you have commissioning, for example, UAV, LiDAR, or even TLS, we need to still go to the site, because the interpretation of the data, for example, discontinuities, still depend on the personal or individual experts or judgment. So to reduce the errors, okay, we still need to go to the site and measure it by ourselves as a representable of the, for example, we have one 20-meter slope, and then we have a TLS or aerial photo or photogrammetry, and we identify the discontinuities geological unity, and then we still need to go to the site to have a field reading and to collect the conventional method of discontinuity, and then we tie back with the geospatial method that we use. Okay. As a conclusion, geospatial technology have been widely used in geoscience application. It helps reducing the cost of manpower, of course, in collecting data, as well as optimizing the time or schedule of project timeline. However, the data and result of any geospatial processing need to be evaluated with professional and combined together with expert judgment knowledge to ensure the data is meaningful and reliable. It's important to have a multidisciplinary professional in executing any project. For example, when we have a geological project, we also need to have a geotechnical engineers, geometry engineers, geospatialists, and GIS analysts. And lastly, is a multidisciplinary approach involve drawing appropriately from multiple disciplines to redefine problem outside of normal boundaries and reach solutions based on new understanding of complex situation. I think that's all for my presentation. Thank you for listening.
I'm seeing some very nice comments here. For example, Fua Mui Hao, she says, it's a very detailed description on geospatial applications in geology and construction and much more. I think if we had students here, they will get very motivated by your talk today. Now, there is a question on the resolution. I think earlier you provided some data on the resolution. And the question is, when you do data fusion to create a DAM, in your system, how long does it take?
Is it a processing?
Yes, for it.
Hello, yes. So the processing, is it? The question means the processing. How long it takes?
The audience member is Lizel. I pronounced that correctly. Yeah. He or she is interested to find out when in your system, when you do data fusion to create a DEM, I'm sure different area, there are different, the size, the various methods. But she wants to get from your experience, how long do you take to create a DEM in the example you showed just now?
Okay, so basically it depends on of course, the area, how big the area of the survey, and then depends on the accuracy or the density of the data that we captured. The more dense the data is, more time we require. Okay.
Correct. So now, also the question follows on, what is the uncertainty, or what sort of accuracy do you have?
Okay, so basically, for example, it depends on what we need in geology. This depend on the purpose of the study. For example, we need to we deploy LiDAR to study debris flow. For example, the key point or the key the important things in debris flow is the boulders itself. So usually boulders size is maybe there's a range of size of boulders. But I think, for example, debris flow, the size of 0.5 meter, for example, is useful in identification. It need to be identified. So we need to set the UAV or LiDAR to capture a 0.5 meter resolution, for example. And it depends on other purpose of the geospatial, or the purpose of the UAV. Okay, for example, in mining. Okay, in mining, if you want to have to calculate the stockpile, of course, we need to we need to have a very good resolution or accuracy. Okay, I cannot give a specific number of accuracy or resolution, but it depends on the purpose of the project, or the purpose of for example, the UAV or LiDAR that we fly.
Yeah, thank you, Farid, for that response. We move on to the next question. Is from Jim L. He's asking you about your Landsat. He said, when you use the Landsat, is it just purely for visualization, or are there some applications for that Landsat in the mining and quarrying?
Okay, so for the example Landsat example that I show to you. So basically in Malaysia, I think there's a few, or even there is no company use this kind of application in minerals and quarrying. But internationally, of course, they use the Landsat to utilize the Landsat in mining and quarrying. So for the question, based on my experience, basically it's used for visualization. And once we identify the different color, for example, different color that shows the different lithology of different rock, we need to go to the site and we check it by conventional or field mapping. Okay.
Yeah, thank you, Farid. Now, next one is just, I think, a comment from Dr. Mahdevi here. Mahdevi says, to overcome the delay based in the case of some bad weather or something like this, so you need to emphasize on the use of the data fusion by using some intelligent technique. This is just a comment. We move to the next one is from Temi Shams. He's thanking you for your presentation, and he'd like to ask you, what's the difference between the risk map and the vulnerability map?
Okay, actually, okay, the difference between vulnerability map and risk map. Vulnerability is the measurement on the element at risk itself. Okay, how vulnerable the element at risk that exposed to the hazard, for example, for landslide. Okay, but when it comes to the risk, okay, it is the matter of vulnerability and how much it lost. Okay, vulnerability is how much exposed is the element at risk, and when it comes to the risk, it goes beyond the beyond the exposure of the element at risk, and it's go to the how much it lost. Okay, so the calculation must include for example, if buildings, the calculation may include the cost of the building, for example. Okay, but for vulnerability, the cost of the building is not incorporated in the calculation.
Right. So thank you for those responses. Are there any other questions from the audience? So I know at very short notice, Farid, you have come and stood in for GS Jaapar. We really appreciate your coming in, and we look forward also to meeting you in the future forums. And with that, let's thank Mr. Farid with the applause as we normally do.
Thank you.
So now we moved on to our final speaker for this evening. Mr. Iskandar also came all the way from Johor, Iskandar Development Corporation. We share the same name, huh?
Yes.
So I introduce Iskandar's topic here briefly. So he's going to talk on the role of geospatial data in the Iskandar Malaysia Urban Observatory System. His full name is Iskandar Sabri Rahmat, and he's currently Vice President of the Technology and Innovation Section, Urban Observatory, Iskandar Regional Development Authority, IRDA. Now, IRDA has a comprehensive development plan laid out until 2025. It lays out the development vision for the region and priorities, its transformation into a sustainable, inclusive, and smart regional corridor within Malaysia. So this plan proposes the development of the Iskandar Malaysia Urban Observatory, IMUO for short, that will gather, update, analyze, manage, and disseminate data concerning the region. This information will then be used to establish baseline data, support development planning, and ensure balanced regional development on a national scale. So to achieve this goal, there will be an advanced regional analysis platform to perform data collation, analysis, and distribution. So the outputs will be used to empower the Iskandar Regional Development Authority, IRDA, to move effective plan and implement targeted programs, such as initiative for economic growth, poverty reduction, improved healthcare, education, greater employment opportunities, and reduce inequality through strategic industry and infrastructure development. Now, Mr. Iskandar Sabri Rahmat has been working with the Iskandar Regional Development Authority for more than 12 years and is currently a member of the Technology and Innovation Key Results Steering Committee. One of the key tasks of this committee is to deliver the Observatory project. So, before joining IRDA, Mr. Iskandar was involved with MSc Cyberport, a public-private partnership spearheaded by the state government of Johor. He holds a bachelor's degree in computer science from University Technology Malaysia, UTM. Over to you, Mr. Iskandar.
Thank you, Mr. Chairman. Distinguished speakers, let me share the screen. Good afternoon, everyone. So today I'll be talking about the role of geospatial data in the Iskandar Malaysia Urban Observatory System. Let me brief you a bit about what we are in the Iskandar Malaysia. So we are located at the southernmost tip of the Asian continent. So the most southernmost tip of Asia itself is located within our region in Iskandar Malaysia. So we have a population of about 2 million based on 2017 projections. And we have excellent connectivity via road, and also we have 2 international airports, which is, we also count Changi Airport as one of our airports because it's very easily accessible through the Iskandar Malaysia or Johor Bahru. We have 5 local authorities within our region, which is the Majlis Perbandaran Pasir Gudang, Majlis Bandaraya Johor Bahru, Majlis Bandaraya Iskandar Puteri, Majlis Daerah Pontian, as well as Majlis Perbandaran Kulai. So we have 5 local authorities within our region, but there's 2 districts. So Johor Bahru district and Kulai is within our Iskandar Malaysia region. Pontian is also part of our area, but only a small part of Pontian is located within our area. What we have in Iskandar Malaysia is we are primarily an economic region. So we try to attract investments, with be it domestic or international investments into Iskandar Malaysia. It can be also foreign. So we are trying to get more economic activities into the Iskandar Malaysia region, but we do not forget about our roles to also empower the local community in terms of the social improvement as well, and also to get the environment, to also not forget the environment while chasing the economic improvement within our region. Okay. Our primary role is to plan, promote, and facilitate the developments within Iskandar Malaysia. We are actually a federal statutory body, federal government statutory body, but our chairman is both the Prime Minister as well as the Menteri Besar of Johor. So they are co-chairman in our organization. So we are formed as an Act of Parliament, Act 664, to deliver on the Iskandar Malaysia vision. So one of the things that, as the chairman just now mentioned, that we have a comprehensive development plan, and one of the plan is to develop the Iskandar Malaysia Urban Observatory. But a lot of people, when they hear about the name Iskandar Malaysia Urban Observatory or Urban Observatory itself, they will think about, are we actually, an observatory is to look at the stars. So an urban observatory is trying to look at the region itself. So what is it that we are looking at is we try to see what is happening on the ground, what are the data that we need to collect, as well as we analyze. After we collect the data, it's not just collecting and telling you what is currently on the ground, but we also analyze it to further understand and to further improve our region. So it's a centralized data center. We collect, update, analyze, manage, and disseminate data. It's not good if we only collect, analyze, and only use it on ourselves. We have to share the data with our team, with our stakeholders as well. It's also a knowledge hub. Yeah, it is not just to improve IRDA, it's not just to improve the region, but we also need to improve the capabilities as well as what our stakeholders can do for our region. We also are a monitoring and assessment center, so we monitor the progress against the goals that we set out to achieve. In terms of IRDA, we set the goals are listed in our Comprehensive Development Plan 2, but we are also monitoring such as the Sustainable Development Goals as well as the Johor State Development Plan. So Plan Pembangunan Mampan Johor. So those goals are also being gathered as well as monitored within our region to see where we are going and whether we are achieving those goals. Are we following the plan, or are we currently going to achieve according to plan? We are also trying to build up our technical services, where we also help other states, other stakeholders to also monitor their progress if they request it from us. So we want to help build and implement policies at the local level. So this is a long-term project. The timeline is we started in 2017. We estimate that it will be completed totally by 2025, but at the first version will be available by next year. So that's our promise to everyone. The most important thing is that when we do this Iskandar Malaysia Urban Observatory, it's about the co-ownership of the system. It's not IRDA's system, but it is also a co-ownership program where we want our stakeholders, be it from the federal, state, or local government, or also from other stakeholders as well, to also be a co-owner of the system. So there's a buy-in, and they are also providing the right data to us, as well as utilize the analytics that come out from the data analytics that we churn out from the system for their further improvement to improve the region. So we are also working together with the United Nations Development Programme, and we have came out with the 3 documents, which is the business plan of IMUO, the data landscape review, what data is available at the moment, as well as data management and policy. This is about how do we manage the data, because there's a lot of government-related data, there's a lot of private companies sharing the data with us, academia sharing information with us, NGOs and whatnot. So those data, how do we manage it? And is there the right policy, or is there a need to improve the policies from our stakeholders in terms of the data sharing process? IMUO is also an enabler for our smart city ecosystem. So we also have our own smart city framework. So there's 6 dimensions to our smart city framework, which is the smart economy, smart governance, smart environment, smart living, smart mobility, as well as smart people. So IMUO is an important enabler of the Iskandar Malaysia Smart City. This is because there's a lot of data being generated, not just by the state government or local government within our area, but also from the various stakeholders, be it from the developers, from the town councils. So those data, what happens? So we collect the relevant data. It's not, we don't collect every single data, but we collect the relevant data that we feel that we need to further analyze. So we collect the data from those connected devices, and we further analyze it and then share with them back. And we also share with other parties for improving their services. So what we want is to have the smart solutions analyze those information and to enable and enhance the better quality of life for our citizens. So that's our primary objective in running the Iskandar Malaysia Urban Observatory. So as I mentioned earlier, we are in this business, we need to share data. It's not feasible for us to gather all the data on our own, because a lot of other people or a lot of other organizations are already gathering the right data. It's just that we need to have that data sharing agreements in order for us to get the right data, the right raw data for us to further analyze. So we are gathering the data not only from the government side, federal government, state government, the local authorities, but as I mentioned, we also get the data from private companies and the academias as well as the NGOs, because not the government doesn't have every single data. There's a lot of data gaps or data not being updated as frequent as what the others are doing. So we are trying to plug in the gaps and to get more realistic information about what is happening on the ground. And then we analyze those information according to the themes. So we have roughly about 7 themes now. So we are looking at data analytics and economy, for transportation, for spatial planning, quality of life, natural environment, utilities, and the social development. So what we do is that after we run this analysis, we share back those value-added data with our partners. This is to enable, this is our tagline also, this is to enable data for decision. So we want to gather the right data to enable and to make the right decisions according to the data. It's not just hearsay, it's not just trying to test out the market, but we make the decisions based on the real data that we have collected and analyzed. As I mentioned earlier also just now, that we do not collect all data. We collect the data depending on the goals that we are trying to achieve. So basically, the sustainable development goals, which is the national as well as local, we are also localizing the sustainable development goals into our local authorities. We are also looking at the goals for our comprehensive development plan 2, and we are also looking at the local authorities' goals as well as the state goals. So those strategic goals, our basis of collecting the relevant data. It can be secondary or primary data. It also covers spatial and also non-spatial data. So what we are doing with those data is we are running analytics on it. We do spatial planning, we do geospatial analytics, we do some predictive analytics as well as prescriptive analytics. A bit predictive and prescriptive we are trying to do, but mostly is currently is scenario planning and geospatial analytics. We are trying to do the predictive and prescriptive mainly in 2022, most probably. So the reason why we're doing this is that for the government is to have a better policy and planning advisory, and for them to also monitor and evaluate their programs. And for the public, for them to also know what's happening on the ground and what is the government doing to better their lives. So from this analytics, it goes back into the future planning. So what do we need to improve in order to achieve a better outcome? So this is always a continuous process where we gather the right data, we do some analysis, we share back with the government for them to do improvement. If the programs are not working, if the program is doing well, how do we expand it further, for example? So this is a continuous process that will never end. We are always collecting the right data on a continuous basis. If we do not have the right data now, we have to collect it from other sources for us to do a better analysis. So this is some of the examples that we did. This is a partnership together with MIMOS. We did a Johor traffic analysis. If you can guess where we are getting this information, 10 points for you. If normally in Johor or maybe in Malaysia itself, most of the data for traffic is being gathered through CCTV. Maybe there's a lot of people on the ground counting the vehicles. Maybe for the accidents on the road, we get data from the insurance agencies or also the police. But in this case, where we did this test, we are actually collecting data from Waze. There's a lot of people using Waze in Malaysia. We are actually one of the top nations in the world that are Waze users, most probably because there's a lot of traffic jams in Malaysia. A lot of these Waze users are using private vehicle owners or private vehicle users. So one of the things that we want to do is to improve our modal split. Currently, it's about 15% of citizens using public transport. We want to increase it to 50%. So a 50-50 modal split. So the best way is to analyze those people using private vehicles. So one of the ways people using Waze is to find out what is the best route from where they are now to their destination. It can be from their home to the office, office to their home, office to their recreational place. I mean, it can be anywhere. So Waze collects those information and we somewhat anonymizes it. So we don't actually know where is your house, but they group it according to areas. So you can see that the top 5 origin and destination. So we can see where are the users coming from. So where are the private vehicle owners? Where are they coming from, the top 5? And where are they heading to? So with this information, I mean, this is also geospatial information coming from the users. So this is also about crowdsourcing information. So this information is being utilized by our Iskandar Malaysia Bus Rapid Transit team. We want to develop a bus rapid transit within our Iskandar Malaysia region. So we are using this to see how we can further improve our route in order to serve these people. Because in order for people to use public transport, it must be very convenient to them. They should not be changing buses too often, then it'll be very inconvenient and they would not take public transport. So one of the best ways is to have a very good route for them, for the private vehicle owners, for them to use our public transport is to see where did they come from and mostly and where they are heading to. So this information is being used at the moment. One of the things is also people reporting on ways. People don't report if they see a traffic accident. They don't call the police anymore. Mostly they just tap on ways, report. So they report car stop on the road. They report about potholes. They report about accidents on ways. This is one of the ways that they collect points. So we can actually share this information. We are also collecting this information, and yes, you can see that there's car stop on the road. There's what is the highest being reported. So there's a lot of cars being stopped on the road in our Iskandar Malaysia region. Construction is also one of the things that people are reporting. Accidents as well as potholes. So people don't actually do reporting that much at the right channels now. People, if there's potholes, they don't call JKR or their local PBTs. They report on ways. So this is one of the ways that the PBTs as well as other stakeholders, they can also take advantage about people reporting on that platform so that they can find out where are these things happening and they can improve it further. Our role in terms of Iskandar Malaysia Urban Observatory is to gather this information, but also to analyze, is these events happening at a certain time of the year? Are these things happening in a certain stretch of the road? So we can actually further understand why is it happening. So it's not just about patching up the road in terms of the pothole, but also to further understand why is it happening. Is it because of the new developments in the region? There's a lot of lorries going around the area, or maybe there's about the quality of the road itself. So there's a lot of ways where we can further analyze and understand what is happening on the ground so that we can better plan for our region. This is also another example where we actually get the data from our immigration department. So this is using the entry and exit points within our Malaysia region. So we can see that this is only applicable for foreigners. So we can see that the top visitors into Iskandar Malaysia, of course, it's Singaporeans. So in the course of about 1 year, we have about 37 million Singaporeans visiting Johor Bahru or Iskandar Malaysia region. And most of the Singaporeans are coming through either the causeway or the second link. It's quite interesting to see 37 million Singaporeans coming into Iskandar Malaysia region is because there's only about 3.5 million Singaporean citizens. So it's an average of about every Singaporean citizens are visiting our region 10 times per year. So it's quite high. So it's quite interesting to see this kind of information. In terms of Indonesians coming into our region, I mean, there's about 3.8 million of them. And mostly they come through the ferries. So this is quite interesting because initially we thought Indonesians and Chinese coming into our region. Chinese is a close number 3. We thought that mostly they come through the Senai airport, but apparently when we look at the data, we see that Indonesians are coming through the ferries, but the Chinese are coming through the second link. So it's quite interesting to see this information, and this is quite important for us to see and to further understand, is because we can do selected targeted marketing. So for example, if our partners want to target Indonesians, they shouldn't advertise at the Senai airport. They should advertise at the ferry terminals. If they want to target the Chinese visitors, they shouldn't target the Senai airport as well, but they should target at the second link. So this information is quite interesting, and for us to further understand and analyze, as well as share with our partners, for them to also share, to also further understand how they should approach when they want to do marketing for these people. One other interesting things that we also do is that we also look at and we also gather data for one of the most polluted rivers in Malaysia. So this is Sungai Skudai. I'm not sure whether everyone knows about this Sungai Skudai, but it cut across 3 local authorities. So it originates it originates from Kulai, Majlis Pembenaran Kulai. It cuts through Majlis Bandaraya Iskandar Puteri, and it exits through Majlis Bandaraya Johor Bahru. So it cuts across 3 local authorities. What's important about this river is that normally it goes at, the river water quality is at Cat 3 or Cat 4, Category 3 or Category 4. It's quite polluted. And this is quite important. It's not just because we have to improve it because of the river quality itself, to sustain life itself in the river, but it is also part of our international agreement because this river actually flows to the Selat Tebrau, the Johor Straits itself. So in our agreement, international agreement with Singapore, we need to, any rivers discharging into the straits needs to be at class 2. So we are actually violating our international agreement with Singapore. So one of the things that we've done is that we collect all of the relevant data, the GIS points on where are the wastes being discovered. At first, there's also one water treatment plant in this area which could only run for three months in a year. So there's about 90 days running, whereby the other balance is they can't run at all because the water is too polluted, so it can't generate clean water. So what we've done is that we in partnership with Department of Environment, the Jabatan Pengaliran Sungai JPS, we partnered with the local authorities to further understand about what is the information that we need in terms of the licenses in the area. At first, that we thought that the river polluting the river is actually the industry, because in Kulai area there's a lot of industrial areas, as well as ladang kelapa sawit in that area. The palm oil industry is there. So we thought that at first the industry is really contributing towards the river quality degrading in this area. But after gathering all the data and with the system from everybody, and doing the analysis, we found that a lot of the hotspot areas of the pollution is not coming from the industry itself or even the commercial areas. It's coming mostly from the residential areas. So we found out after getting the data, we analyzed it further. We started scratching our heads, and then we worked together with the local authorities to further understand the data. Why is it coming out that way? Apparently, a lot of the residential areas are actually built 50 years ago, 1970s, 1980s, and we found out that they did not properly maintain their septic tanks in those areas. There's no centralized septic tanks, it's all individual, and they have not been maintained at all since being built. So after understanding those information and presenting the data, Department of Environment and JPS actually worked together with us to maintain those septic tanks. It's not their areas, but in order for us to prove this is the reason why the river is being polluted, they work together with us. So we do the enforcement, we do the maintenance, and then it got better sharply. So this is one of the success stories that we like to tell people. This is the reason why it is important for us to collect the right data and across PBT boundaries, across agencies, because if we work in the normal way, we only look at very piecemeal data. I mean, the local authorities are only looking within their area. There's 3 local authorities within this river. So after we gather all the information, we can actually see and further understand what is the cause of this, the pollution itself. If we were to do it the same way, is always to clean the river, not treating the cause, or we make assumptions that the industry is doing this or the commercial area is doing this, but it is actually the residential area that is actually contributing the most pollution within the area. So it's quite interesting to see. And the success story coming from this is that, of course, the water quality for the river rose from normally category 3 to category 4, but now is between category 2 and category 3. And the water treatment plant that I mentioned earlier that could only run 3 months in a year, it is now running 24/7 for the full year. So it is one of our success stories that we are most proud of. One other area is that we are also looking at doing the disaster management framework for the Iskandar Malaysia Urban Observatory. In light of course, the recent case is the COVID-19 crisis. So we want to help the region as well for disaster management. So if there's any disaster, we are available. We are able to also assist in terms of having the right data for them to further analyze and understand about how do we improve the crisis. So one of the things that we did during the recent COVID-19 crisis is we developed the dashboard. This is together with Esri Malaysia. So we collected in partnership with the Johor State Government as well as the Jabatan Kesihatan Negeri Johor anonymized data, of course, but we are able to plot where are the areas of the cases, the case ID, where is the mukim, whether it's asymptomatic or symptomatic, what are the type of the onset types, the red green zone areas and whatnot. So this information previously it is collected by JKNG. Of course, this is where we get the data from, but a lot of the analysis being done is manually. They are being done either through Excel, pivot table and whatnot, but a lot of it being done manually. So what we did is we tried to digitize it, put it on a map, so it's very simple. I mean, they just need to enter new data and it's automatically being updated. In this case, a lot of the data you can see is in Keluang as well, in Johor Bahru. So those are the areas most impacted in our Iskandar Malaysia region. We are also did some insights to further understand and make and let the relevant authorities further understand how the disease is being progressing within the region. How does it link to each other? So you can see there's a lot of clusters being in number 3 there. There's a lot of clusters of the COVID-19 crisis, cases in Iskandar. How did they link between each other? Is it a lot of them between neighbors? Is it between family members? Is it between friends? A lot of cases, symptomatic or asymptomatic. If an asymptomatic person infects another person, does it become asymptomatic as well? So those are the types of analysis being done by the relevant authorities using the system that we have developed together with Esri. So this is quite interesting to see during the cooperation that we had during the COVID-19 crisis. One of the things also that we did is to have, this is post-MCO cases. Just now is mostly about during the MCO itself, what do we need to do? But post-MCO, this is about having that new normal. So we are using our Jejak Johor app to gather the data for us. So we only have the phone number, the close contact phone number, what are the date of the close contact and time of close contact. So we are using Bluetooth technology to track the contact. When did they contact each other? So those information we are only collecting data for those users that install Jejak Johor app if they are within 1 meter of each other. So those data is being collected by the IRDA system on a daily basis. So what we do is we have that social distancing compliance reporting to the state government. So we inform them on a daily basis if there is, for example, after the scanning into the premise, is there multiple scans? How many scans are there? If a premise has a limit on how many people can enter, we can actually tell the state government if there's a violation of that policy and what is the capacity for the area. So it helps the state government to further understand what is happening on the ground. Is social distancing compliance a thing by the citizens, as well as if they want to do enforcement? Currently, they are one is either they go around and checking the premises whether they are enforcing the social distancing compliance, or people are actually reporting. So we are trying to make it easier for them to do enforcement, as well as for them to do the checking on a daily basis. What we have done is that what we want to do with the Iskandar Malaysia Urban Observatory System is to have an improved decision making for the government. So this is quite easily to improve the government and outcomes in terms of transportation, welfare, crimes, and others. We want to also improve the agency's efficiency. So as I mentioned earlier, is for them to have an easier and focused enforcement, so they don't have to go around, but they have a targeted enforcement areas. And to enhance policy making. If a policy is not working, what can we do to improve the policy to better, for example, social compliance, distancing, or improving to attract the investments. If investments are not coming in, we can analyze why, and to improve the incentives, for example, and improve the city management with the authoritative data. It can be spatial data, it can be non-spatial, it can be from other agencies, it can be from non-governmental sources as well. And lastly is to enhance the transparency. This is about telling the people what we are trying to do, how we can do better, what we are planning, what is happening on the ground, and for them to understand why we are doing certain decisions. So because this is backed by data, it is not simply be suka-suka saja. This is about analyzing with the authoritative data for us to do better decision making. All right. So that's it with my presentation. I hope if there's any questions, I can answer them after this. Thank you very much.
Yeah, thank you very much, Mr. Iskandar. So very informative talk and a very good example of how GIS now being utilized at the ground level by the people, empowering the people to make decisions, empowering the people to give information back to the relevant authorities. Particularly, I'm impressed by your Jejak Johor apps, which at this time of the COVID-19, it can be so useful in giving feedback to government when people are getting somewhat, in my opinion, getting overconfident. From what I gather from countries which have already gone back to normal stage, then after a while, they get a surge in the cases because of the overconfidence. The latest I got news was from Tokyo this morning. They're having an upsurge of the cases in COVID-19. Now, with your Jejak Johor apps, from your experience, how is the response of the authorities? For example, if I go into a supermarket and I find that people are not lining up according to social distance, they are so close together, or two lines are almost fused together because of the lack of space in the market. Now, if you take a picture of that, can you upload it into Jejak Johor and then submit it to the local PBT? Will they come immediately, or will they come the next day and talk to the manager, or what happens?
At the moment, unfortunately, the Jejak Johor app does not have that function. It only records on the background if you are in contact with another Jejak Johor user. But the PBTs, if you are actually, there's a lot of, there's a link in all PBTs for you to actually, report if there's any violations, as well as the, in Johor itself, it's through the Jabatan Kesihatan Negeri Johor. If you actually report this kind of violations, then yes, they will actually go and see for themselves what is happening on the ground and how can they further improve. In the worst case scenario, there has been several instances where they actually close the premise for any visitors for a few days. So this has happened a few times in Johor itself. But what we're trying to do is that to minimize people reporting, they don't have to report with our data that we collected. We try to automate the process, and we try to enable the respective authority figures to do targeted enforcement. So rather than being reactive, people reporting, we want to be proactive. So using the data that we collected, where should they go and try to minimize the violations against the social distancing.
Sure. Mr. Iskandar, you made a very good example just now about the use of waste, for example. You said people generally, they don't like to report to JKR about a pothole, but they will report in the waste database. When they report in the waste database, then we found that there is action by other users. Other users benefit from such information. So similarly for COVID-19, if you can incorporate further functions into the Jejak Johor, then I think people feel comfortable. They take a picture. It's not so convenient. For example, if they want to report to the Jabatan Kesihatan, they need to find a telephone number, they need to find out email, and they don't know whether they're sending to the right person or whether they'll get action or whether they'll get more questions and so on. So people like to give information in a way that they feel secure or safe or comfortable. So if you include the simple function like if they can upload a picture and they give the location, which is from the, the location available on my location or whatever on your handphone, then the authorities can move in. I personally saw such things earlier in the COVID-19 when I told the manager, they are a bit slow because sometimes they are afraid to talk to customers directly, and also sometimes there is an issue. Some people can get bashed up as well. But with your application, if you build it up, then there is a concrete evidence and the authorities can follow up and your database can become the reference point. And I tell you, this is so important contribution you guys can make, because at the moment there is no vaccine yet for COVID-19. We feel so nice, our figures are very low. Malaysia is well in control of the situation. Well done to all those authorities. But remember, the virus is not gone yet in the world. So the action taken now to prevent it is so important. And the GIS you mentioned just now can play such an important role. So I will certainly encourage you to look into building those functions. Now, I'd like to move on to another question here given by the audience here. It says here, although this might not have been a boundary with Iskandar region, Strait of Johor Malacca, I would like to know if your observatory includes marine oil pollution. Will you cover that area of marine oil pollution, say if it comes into your river or the nearby area? Over to you, Iskandar.
Okay, thank you for the question. I think it was Mr. Temi Shams or Miss Temi Shams, not sure. At the moment, as I mentioned earlier, we are actually planning for a proper disaster management platform under the Iskandar Malaysia Urban Observatory. For the next year, or within this year, we are actually trying to get the right analysis or analytics and also the right data for us to try to prevent or mitigate crises. There's three actually that we are trying to do. The first one is, of course, the COVID-19 crisis that we mentioned earlier. So we are already using that, and we have proof of concepts as well as running systems for that crisis. The second one is about the flood, and the third one is about industrial or community-based issues, such as you may know, we had issues in the Sungai Kim Kim earlier, I think 2 years ago, or was it last year? So we are trying to tackle these three first before looking at others. But definitely, there's a lot more other disaster management things that we have to do, including, of course, is oil spill. Even though we have the boundary, but it's only a bit on the Iskandar area. But oil spill, chemical spills, of course, all includes that. But for this year, we are only focusing on three. But I'm not saying no. But definitely, other disasters will be taken. Will be under our urban observatory as well. So yes, now no, but in the future, yes.
Yes, thank you for the response. So this also covered the second question about the sustainable marine oil management. Any other question from the audience? I know it's about 5 o'clock, but online you are quite free to move about and also ask questions. I'm seeing a lot of positive comments here from the audience. For example, very informative presentation. Big thanks to all presentation. Muhammad Ibrahim says very beneficial. Pua Muihau says, thank you, Mr. Iskandar. Splendid, Mr. Iskandar says, Nazan Achok, and so on. So,
thank you, everyone.
Yeah, you're most welcome. So if there are no other questions, I would like to thank today all the three presenters, starting earlier from GS1 Ibnul, Bahar bin Wan Ismail, and followed by Mr. Farid, who stood in just now for GS Rasid. And so finally, the third presenter, Mr. Iskandar, Sabri, Rahmat. So please give them all a big applause, as we normally do. Now, going on from that, I would also like to say special thanks to all the audience who have been watching from 2:30 right until now. This is one of the very excellent sessions we had with three eminent speakers coming in and three speakers in the afternoon. Normally we have only one or two. Today we have three. A special day today. And also I'd like to say a special thanks to the Secretariat, especially to GS Dr. Dinesh, who helped set up all the technical stuff to make today's thing happen. And also the Secretariat at the background who worked so hard to support this event. Thank you very much, dear all. And we see you again next time.
Sure.
And we bring that to a close today. Thank you very much.
Thank you.
Thank you.